Okay, for the last couple of sections, we were doing systems of linear equations, right? So first we had substitution and elimination, then we had Cramer's rule. Those were all linear equations. Today we're still going to have systems, but one or more of the equations may be non-linear. In other words, look, this one's a quadratic, this one's a linear, but this one's a quadratic. So Cramer's rule doesn't apply anymore. Cramer's rule is for linear equations, but substitution and elimination still applies. So I would just do the same thing. I could either solve one of these for x or y. Now in this, and I wouldn't really want to solve for x because I got to be careful, and if I took the square root, I'd get a plus or minus. I'd have two parts to plug in. Okay, but I could solve this for y, or either of those for x or y. Or I could notice, hey, if I use my elimination method, I just add them together just like they are, right? And x squared plus x, now that is x squared plus x, right? Those are not like terms. They can't be combined. Before we just had an x plus x, and that's two x's, right? X squared plus x squared, two x squareds. But x squared plus x, that's x squared plus x, equals 2. And I get a quadratic equation, right? A quadratic equation means I'm going to try to factor it. X squared plus x minus 2 equals 0. Are there two numbers that multiply to give 1 times negative 2, and add to give 1? Yes. How about x plus 2, x minus 1 equals 0. So we know that x is negative 2 or positive 1, right? X is negative 2 or positive 1. And now I just have to go back and find my y value. Okay, so I can plug into either of these equations, and the easiest one to plug into would be right here. So if x is negative 2, I'm going to plug it in right here. So negative 2 plus y equals negative 2. Add 2 to both sides. So y is 0. If x is 1, plugging it in right here, 1 plus y equals negative 2. So y is negative 3, giving me the point negative 2, 0, and 1, negative 3, right? Now technically, here we can put these in brackets. I think your MyLabs Plus already has that to show I've got two answers, but they're both coordinates, right? So it's the same thing, except our equations may not be linear. Okay, so thinking of that, just keeping this solution in mind, if we want to visualize the graphs like we did, remember we had one of them was a line and one was a parabola. So we could still have no solution, or it could touch at one point, or here's what we had then. And that's the most number of solutions. So it kind of helps sometimes, if you know the shape of the graph, to think about, oh, what's possible when you're looking for your solutions. Okay, so solve the system. What method do you think we're going to do? That's right, it looks like to me, if I just add these together, I eliminate my y's automatically. Now they're both x squared. So 1x squared plus 2x squared is 3x squared, right? 12. Okay, now I only have x's, so I can divide by 3. And then x squared is 4. Now don't forget, when I put the square root in the problem, that's the distinction. When I add it to a problem, that's when I have to add the plus or minus. All right, so I know that either x is 2 or x is negative 2. So now let's see what y is. I can plug these into either equation. I'm going to plug them into that top one. My numbers are smaller. So if I plug in a 2 for x, I have 2 squared plus y squared equals 4. Or 4 plus y squared equals 4. So subtract 4 from both sides, and y squared is 0. Now when you take the square root of 0, it doesn't matter if you do plus or minus, right? So here's one solution to 0. If x is negative 2, let's plug this in, negative 2 squared plus y squared equals 4. And look, we wind up at the same place with this one. That doesn't always happen, right? But with this one, we wind up at the same place. So I know I'm going to have another y equals 0. So my solution set are these 2 points. Okay. Now let's think about this just for a minute. This is a circle I hope we recognize, right? So that's the circle. And this, if we have an x squared and a y squared, we'll just say circular. We didn't talk about these. Technically, these are hyperbolas. So instead of a circle, it's like as if we cut it and split it open and reflected them. So technically, I could have had 4 answers there. Okay, we only got 2, so it must have been maybe something like this. Right? Or you could have none. Or the 2 could have been something like this, right? We could have had 2 answers like that. Anyhow, but that only happened because this was 0. If it had been any other number, I'd have had a plus and minus, and then I'd had 4 solutions, which is the maximum I could have for that one. So it's kind of nice to think about the graph sometimes, just to double check ourselves. If we know what the graph looks like, right? Which you may be thinking, oh, I've got this extra xy term in there, I'm not sure what it looks like. Okay, that's fine. Let's just use our regular substitution and elimination then. Okay, so hey, we might notice that if I just multiply this one maybe by a negative, I'm going to eliminate my x's and y's immediately. So that looks good. So let's multiply everything through by a negative. That'd be a negative, that'd be a positive, that'd be a negative, and that'd be a negative, right? Just multiplying by a negative. So this is gone. Then I have 3xy's plus 1xy, so 4xy. And then this is gone, equals 22 minus 6, 16. Let's divide by 4. So I have xy equals 4, but I don't care what xy is. I need either an x or a y, right? So it doesn't matter. I'm just going to divide both of them by x. Okay, so far we have y equals 4 over x. So I'm going to go back and plug into one of these equations, that bottom one, since it's a simpler one, and see what happens. Okay, this is y. It doesn't really look like a y, but there's y. Okay, so we have x squared minus x times 4 over x, right, plus 4 over x squared equals 6. Okay, so let's see what we have here. We have x squared. Oh, that x and that x, so I'll just have minus 4 plus 16 over x squared equals 6. What do you think we're going to do with that? Yes, it's an equation. Get rid of the fraction. Get rid of the fraction by multiplying by that denominator. So multiply by x squared, multiply by x squared, multiply by x squared, multiply by x squared. Okay, so now we have x to the 4th minus 4x squared plus 16 equals 6x squared. Okay, so let's set it equal to 0 because it's a polynomial. I'm going to try to factor it. by some method. Okay, so minus 6x squared minus 6x squared. Okay, so x to the fourth minus 10x squared plus 16 equals 0. Hey, this has 3 terms. And if I double this term, it is sitting right there. This is quadratic in form, so I'm going to let u equal x squared, right? Just the variable part. That means u squared, x squared squared, is x to the fourth. So I can replace x to the fourth with u squared minus 10u plus 16. We never forget anything in this course. That's why it's so awesome, right? Got to know all this stuff for our whole math career. Okay, now I can factor that. 2 numbers that multiply and give 1 times 16 and add to give negative 10. How about negative 8 and negative 2? So I know that u is 8 or u is 2. But don't forget, I don't care what u is, I need x. U is x squared. Okay, so x squared is 8 and x squared is 2. That means x is plus or minus. Now I'm going to go ahead and simplify this in one step to save room. I'm going to change this to 4 times 2. Square root of 4 is 2. 2 square roots of 2. Okay, same thing here. X is plus or minus square root of 2. All right, I'm going to erase this. I'm going to put my 2 answers up here. X equals plus or minus 2 square roots of 2. And x equals plus or minus square root of 2. Okay, I wish I had a way to erase quicker than this. I can either erase the whole thing. I think I can remember that. Let's erase the whole thing. So we got 2 square roots of 2 and just square root of 2. Okay, so x is plus or minus 2 square roots of 2 and x is plus or minus square root of 2. So look, I've got 4 x values. I've got to plug those in. This is the easiest to plug into and see if I can get some y's. Let's start with positive 2 square roots of 2 for x. So 2 square roots of 2 squared minus 2 square roots of 2 times y plus y squared equals 6. Okay, so this would be 2 squared, and then this part would cancel. So 4 times 2, 8, minus 2 square roots of 2 times y plus y squared equals 6. Okay, so now we've got, I'm going to put my y squared over here, y squared minus 2 square roots of 2y. And if I subtract my 6 from both sides, you know what? I could do this, but let's okay, let's go ahead and finish this. So subtract my 6 from both sides, and I'll tell you why I realized something. So subtract 6 from both sides, so plus 2 equals 0. I really can't solve this equation by factoring. Right? The y is not under the square root, so that's a numeral. It's a quadratic equation. Okay. So let's go back to when I'm thinking, what happened? Remember in the beginning? Okay, so we got to know what to do in particular situations. And sometimes we don't know until we get somewhere and have to back up. So I got my x's. Let's go back to where we first got our equation, right? I multiplied all these by negative so that these were eliminated. And we had 3xy plus xy, so we had 4xy equals 22 minus 6 is 16. So xy equals 4. Here's another equation with still an x and a y, right? Typically when we do this, we get one variable, but notice I still had to solve this, okay? And I solved it for y equals 4 over x. I think I probably solved for y, whichever one I solved for. Y is 4 over x, and x is 4 over y, and then we plugged back in, which I had to because right now I can't solve this. They each have an x and a y, so I can't solve either one, so I had to plug it back in. But now I have some specific x values, which normally we get our x value, we plug back in, but we already tried that and it was difficult. So let's go back to this equation, which we had erased it, but if you're doing this on your paper, you'd have it up there. Here's another equation. This is the much simpler equation to plug in, so let's plug them in right here. Okay, so we're going to take this one. All right, so let's do if x is 2 square roots of 2, then using this, we have y is 4 over 2 square roots of 2, or 2 over square roots of 2. Okay, so there's one solution. We have the point 2 square roots of 2. We have the point where the x value is 2 square roots of 2, and the y value is, hey, we can't leave that. We better rationalize that denominator. So remember how we do that. Square root of 2, square root of 2. So we have 2 square roots of 2 over 2, or square root of 2. Okay, so there's one solution. Right? Had to backtrack because we couldn't solve that equation. That's all right. Then just backtrack, go back to one that you can solve, and plug in. All right, so we've got a square root of 2 here for that one. Again, for the sake of room. Okay, so now let's try what if x equals negative 2 square roots of 2. Well, let's plug into that equation. Y would be 4 over negative 2 square roots of 2, or 2 over negative square roots of 2. Once again, we can't have that. So if we multiply numerator and denominator by 2 square roots of 2, we get negative 2 square roots of 2 over 2. So negative square roots of 2. All right, so here's another one. We can have negative 2 square roots of 2 for x, and it corresponds to negative square roots of 2 for y. Plugging it in, we had negative square root of 2. All right, now let's let x be just square root of 2. If I plug it into y, I'm going to get 4 over square root of 2. We can't have that, so let's rationalize that denominator. So 4 square roots of 2 over 2, or 2 square roots of 2. Okay, so here's another solution. When x is square root of 2, y is 2 square roots of 2. And last one, let's let x be negative square root of 2. So y is going to be 4 over negative square root of 2. Rationalize that denominator. So 4 square roots of 2 over negative 2. So negative 2 square roots of 2. So there's our last solution. When x is negative square roots of 2, y is negative 2 square roots of 2. There's your solution set. Okay, these kind of are the very most complicated ones. Notice how much more complicated it was than the other two. Okay, most of them fall in the easy to mid-range, with this being very complicated. But you will have one like this. So if you get stuck, back up and say, you know, if you wind up with an equation you can't solve, back up, take another route, find another equation. Okay. So look at this one. Look at how it's different. I can't use every other one, and most of the time my go-to solve a system is the elimination method. I think that's probably true for most people, but I can't use it on this one. I can't combine these terms, this is an xy with an x, or these terms. Elimination doesn't work at all. I have to use substitution to get me started. Okay, so I'm going to take this one just because it's a one step to solve for either x or y. It doesn't matter what you solve for, which equation or which variable, but I'm going to take this one and I'm going to solve for y. So y is, and it doesn't matter which one you do, negative 15 over x, right? And then I'm going to plug that in to the other equation. So 4x plus 3 times negative 15 over x, because I'm going to plug that in for the y, equals 3. Okay, so let's multiply those together. 4x minus 45 over x equals 3. Oh my goodness, what do I do? Get rid of the fraction. Yes, get rid of the fraction. Multiply everything by the common denominator. And then we wind up with 4x squared minus 45 equals 3x. It's a quadratic, so let's try to factor it. 4x squared minus 3x minus 45 equals 0. Okay, so I need two numbers that multiply and give negative 45 times 4 is what, 180? Always double check your math, and you know too, my math. All right, so yeah, I think 180, and add to give negative 3. All right, so what are we thinking here? Let's just start with anytime a number ends in 10. I know I've got an 18 and 10, so that's negative 8. I'm not too far off. Let's see. Oh, what else could I have here? I could have 20 and 9, but that's not going to do it either. I need... These numbers need to be a little closer together. So what is 180 divided by 12, maybe? Oh, 15, woohoo. Negative 15 and 12. Just practice at factoring, knowing what your goal is. I need this to be negative 3 instead of negative 8, so these numbers needed to be closer together, not farther apart. So negative 15 and 12 is negative 3. Okay, so we can rewrite this as 4x squared plus 12x minus 15x minus 45 equals 0, so that I can factor by grouping. So I can factor a 4x out of those first two terms, and that's going to leave x plus 3. And then I can factor a minus 15 out of the next two, and that's going to leave x plus 3. Now we can factor the x plus 3 out, and that leaves 4x minus 15. Okay, so x is negative 3, or x is 15/4. Now that I know what x is, I've just got to find y. And notice, here's the handiest place. I've already got it solved for y, right? Should have caught that really in that other one, but I just erased it all and wasn't thinking. So, but it was okay to do that. And then it shows us, oh, what happens if I get stuck? Go back and try again, right, with a different equation. Okay, so if x is negative 3, then y is negative 15 over negative 3, or 5. So there's one coordinate, negative 3, 5. And over here, if x is 15/4, okay, y is negative 15, don't forget what this is now, over 15/4. So there's a couple of ways you can handle this. You can multiply the numerator and denominator by 4. That's what I would do. Or if you just recognize this as negative 15 divided by 15/4 and work it out as dividing two fractions if you don't recall, you know, how we really simplify these by the time we get to this point. Okay, same thing as any fraction. Numerator and denominator by the same thing. So negative 60 over 15, which is, what, 4? Negative 4. Okay, so our other answer is 15/4 and negative 4. Okay. Let's see if we have anything else. Yeah, one more. Okay. So this one, I can use back to using my elimination. So I'm going to multiply maybe everything up here by negative 3, right? Negative 3. And since I have a black pen here, which I didn't realize, I'm just going to make this negative 15, right? I've just multiplied everything by negative 3. So now when I add them together, 4x squared minus 3x squared is x squared. But this plus 3x minus, plus 3y squared minus 3y squared is gone. And 11 minus 15 is negative 4. I don't care what x is though, right? So square root both sides. That means x is, don't forget your plus or minus, and remember that negative has to come out as an I. So that's 2i. Okay, it's okay to have complex solutions. Okay, means we couldn't graph these actually, right? We would not be able to graph these, but we can still get solutions for them. Okay, now that I've got one solution, I'm going to plug it back in, and this is the easiest one. Numbers are smaller, so I'm going to plug those values in here to get my y solution. So if x is the positive 2i, then I would have 2i squared plus y squared equals 5. Okay, remember every I squared is negative 1. So this would be negative 4, right? 2 squared is 4 times negative 1. So negative 4 plus y squared equals 5. Let's add 4 to both sides. So y squared equals 9. So y is plus or minus 3. Now that means I've got two solutions that go with that, two y values that corresponds to that x. So 2i3 is a solution, and 2i negative 3 is another solution. Now, let's see what happens if x is negative 2i. Plugging it into that same equation, we get negative 2i squared plus y squared equals 5. Okay, well, this is going to be the same thing, right? Because if you square a negative, it's the same as that. So negative 4, because negative 2 squared would be 4, but I squared would be negative 1, right? So negative 4 plus y squared equals 5. I wound up with the same equation, so I know I'm going to have the same answers. So also, when my x value is negative 2i, it's going to correspond to 3 and negative 3. So there's our solution set. Okay. Systems of nonlinear equations. Let me know if you need anything. See you next time.